Hello, my name is Brian. Welcome back to another video. Uh, Before starting off, I want to give a huge shout out to my friend John. Me and him made this presentation back at this WashU program where we took environmental science together, and we had to create a presentation about biofuel. And here I am presenting it on YouTube. So, about biofuels. So, biofuels are renewable, carbon-based fuel produced from organic matter, also known as biomass. It is considered to be carbon neutral and more sustainable than conventional fossil fuels. Many kinds of biofuels, ranging from solid to liquid to even gaseous forms, also known as biofuels. Bio, Biofuel can serve as a petroleum substitute, as it is nearly identical to petroleum based fuels. So, the kinds of biofuels, so we see here at the left, we see biofuels, and as you more commonly start seeing, you see biodiesel, a type of gas that you use for your cars, right? But for diesel exclusively, and then we see a, a ethanol compound, a methane compound here, and yeah. So then here we see the different generations of biofuel. So we have our first, our second, and third, and fourth. So with our first generation, this was like the most first, the most latest, or I guess the oldest biofuel. So our first generation was when we would take waste from produced from farms. So this could be like waste produced from corn, from sugarcane, or from lumber, which would then be remodeled or altered into your biofuel, whether that's biogas, biodiesel, or bioethanol. And then we see in our second generation, this one came to be a bit more newer, right? We saw manure was a great source of energy and produced biomethanol. We see, especially manure, where farmers raise cattle. They tend to use this a lot because it's very sustainable and a great way to make sure you use up every part of the cow. Straw, city waste, nutshells, right? And then we go into our third generation, right, where we see microalgae, algae, and we're seeing that there's like farms that are being made to raise algae and actually be used to create energy or biofuel and are more newer, right? As we see algae here, where we see the synthetic biofuels, where we actually see like algae farms right here in this small image to the bottom right. So biofuel supply chains. So going more into detail about the cycle of biofuel. So we start off at farms, right? They cultivate looks like wheat, and then any waste produced from this farm is then brought at the farm cooperative, where it is then in turn processed and then brought by a truck into a ethanol plant, which it is then broken down, and then from there on it can be brought either through the truck or through a rail to the terminal for fuel blending and storage. So this is where we start seeing it gets enhanced, where we see it catalysts get mixed up with the broken down uh, waste produced from the farms. And then and then we go, and after that, after it is I guess enchanted in a way, if you will. It is brought to the gasoline, where you see your biodiesel, and you as the consumer can purchase biodiesel and use it. So how it works? So once again, biomasses are broken down by high or low temperature deconstruction. So again, review: biomasses are agricultural products as food, as forest residue, animal waste, and or other organic matter. So when we talk about high or low temperature deconstruction, it's different ways of how we break down biomasses. So first off, there's high temperature deconstruction, which is its name, right? It's extreme heat and pressure to break down solid biomass into liquid or gaseous intermediates. And then these intermediates are separated and then sent for further processing, as we saw where they are, processed with catalysts to be upgraded, if you will. Low temperature deconstruction is more of a biological and chemical process. So this is where we see enzymes or chemicals that break down feedstocks into intermediates, simple sugar building blocks. The sugars are then fermented, producing ethanol and biogas. So then, going with upgrading. So after the deconstruction, after it's broken down, whether that is through high temperature deconstruction or low temperature deconstruction, intermediates are further processed for a finished product, which can be achieved through, once again, biological or chemical processing. Microorganisms ferment sugar or gaseous intermediates into fuel blend stocks and chemicals. Ethanol and alkanes such as methane are produced this way, right? Sugars and other intermediates, steams can be processed using a catalyst to cease unwanted or reactive compounds to improve storage and handling properties. So, why should we use biofuels, right? So we can use biofuels because it's something we can keep on using and redoing, right? So whatever waste is produced from biomasses, right, from forest residue, we can process that and make energy, even from waste that is produced back to that we don't use for energy. We can always use that back to fertilize and possibly work as compost and give that back to the trees or the plants and further ferment or fertilize, if you will, the ecosystem. So why should we use biofuels? Once again, biofuels can serve as a substitute for petroleum, which we know petroleum is bad for the environment as it releases toxins into the atmosphere. While biofuels is more sustainable and more reusable, and it's like this newer way of creating energy, and it's great. It's all great, right? So, energy return on energy investment. So, how effective, in other words, how effective is biofuel? So, because biofuels depends on many outside factors such as weather and agriculture, as well as having many types, different kinds of biofuels have higher EROEIs than others. Ethanol's mean EROEI, according to article by A.S. Hall, is 5 to 1. But this is because the data in the sample was skewed by several outliers. Based on this, while ethanol is not a heat sink, it is still not a profitable energy source, with most sample EROEI ratios being below 3 to 1. So the future of biofuel. So right, where do we see this going? The use of biofuel continues to flourish in developing countries as their go-to sustainable energy choices. Benefits are lower in developed countries with higher energy needs and more varied economies. Biofuels demand in the U.S. is currently on the rise, increasing by 6% in 2022. Availability: biofuels are mainly used as substitute for petroleum-based products used in transportation. Biogases are also used as a substitute for natural gas products, and we see in this graph where biofuels are mainly used. European Union, the U.S., and Brazil, and we see here the smaller are like developing countries or countries that relatively can afford the infrastructure to use and create biofuel. So biofuel consumptions, we see this graph that is in 1,000 barrels per day. And quick thing, the right away we can notice that the green countries are the ones that use the most barrels per day, red being less. And we see, as we saw with the green revolution, where Africa tends to be an outlier. They tend to not have the resources to use biofuel. While we see in developing countries, countries with a higher, richer countries where they can afford biofuel and thus do end up using more biofuel. So, U.S., Brazil, China, Indonesia, and Europe consume between 74 to 12,000 barrels of biofuel daily. So now let's get into the problems about biofuel. So biodiesel's combustions can result in higher amounts of nitrogen oxidants relative to petroleum diesel. Because fresh crops are also used in the production of biofuels and gases, some argue that This should rather be direct to food production, right? So it's should we use fresh crops for our own consumption, or should we use fresh crops for our energy use, right? So it's this big dilemma where it's like, should we feed ourselves, or should we create more power for ourselves? As we see, what's it called? The stage five in the demographic transition model, right? Where it's like, is does food production also grow, or is it geometric, where it's like, um, it won't catch up to our population growth, and we must do something about it, right? Okay, mitigating these problems. So, like, how can we control these problems that we just mentioned? Excuse me. So, when burned, biofuels generally produce fewer emissions of particles, sulfur dioxide, and other toxins than their fossil fuels derivative counterparts, especially coal and oil. So it releases fewer emissions than their derived counterparts. Biofuel petroleum blends generally result in lower emissions relative to fuels that do not contain biofuels. Research into non-edible plants for use in first generation biofuels to replace crops such as corn and wheat is underway, right? So, right where we talked about here in our second bullet point, where it's like fresh crops are also being used, and we're arguing, should we use that for our own food consumption or energy, right? We're thinking about unedible plants to create energy. So now let's look on to economic pros and cons. So three pros about biofuels is that it reduces the need to import petroleum and natural gases. It mitigates the need to drastically remodel infrastructure that is based around carbon-based fuels, and it reduces waste and pollution production. Now, economic cons. It requires significant investment in infrastructure and technology. It is a complex and expense. It is a complex, expensive, and influenced by factors like weather and crop yield. So it is not 100% reliable as other energy sources, and it is not widely available due to the need for infrastructure investments. So, environmental concerns and health concerns. So, although pure ethanol is non-toxic and biodegradable, it should still be transported carefully due to its flammability. The effects of biofuel production on biodiversity and ecosystem health is still uncertain. So, it's relatively new, and we must have to do further research about this energy source. And humans may be exposed to dangerous chemicals caused in production process. Once again, biofuel is still something that is relatively new, and we're still working on understanding more about biofuel, how we can actually use this to uh, improve it and make energy more efficient. And thus, we don't really know like much in detail about the negative effects of it. And yeah, that's it. This is our bibliography, our sources, right, images, and yeah, thank you.